All right. Hello, everyone. Thank you so much for participating and watching this virtual STEAM night focused around engineering. We're sorry for the slight delay. We had a few issues going on, but we are all set and good to go for tonight. But thank you guys again so much for tuning into this upcoming STEAM night, and we're so excited that you're here with us. So before we get started, we just have a few quick announcements. Be sure to follow us on our Instagram and Twitter accounts. And we also do have a Facebook account now, which is also the Literacy INIT. So be sure to follow us on there to make sure that you can stay updated on all our upcoming events, especially all of our events this summer. On top of that, I just wanted to talk a little bit about our eCamp before we get started with our STEAM night. So this is a virtual summer camp program for students all the way from 6 all the way to up till 17. So you can sign up throughout the upcoming few weeks. And we also need high school volunteers to help out. So if you're interested in volunteering and you don't have anything to do this summer, this is a great opportunity to get involved in the greater community and help students during this time of uncertainty. So this is a really great program. If you want to register your child or if you're interested in volunteering, you can send us an email or just go to literacy-initiative.org/ecamp. So jumping right into our presentations for tonight, we have three great presenters. We have Jillian from the University of Michigan. Her major is in computer engineering. We have Meghana, who is currently at the University of Pennsylvania, and her major is in bioengineering. And then we have Arya, who currently attends the University of Colorado Boulder, and her major is in mechanical engineering. So as you can see, we have a lot of great presenters tonight with a lot of diversity in what their majors and minors are. So we're really excited to get started with tonight's presentations. So let's kick it off with Jillian, who will be talking about her major and her experiences in college.
Thanks so much for the intro. As you mentioned, my name is Jillian, and I am a rising senior at the University of Michigan. I'm really excited to be joining you guys today. Let me go ahead and just share my screen. I think you need to enable the screen sharing, and then I can go ahead and show you guys the little presentation I have today. All right, perfect. Here we go. Okay, sweet. All right, so my major is computer engineering, as I said, and just to start off, I want to preface, this is a pretty cursory overview of what computer engineering is. One of the main points about computer engineering, and actually one of the reasons why I picked it, is that there are so many applications and there's so many things you can do with it. And so there's only so much I can explain in 5 to 10 minutes. So really would encourage you after this presentation, if there's something that sparks your interest, definitely deep dive and do your own research into it, because this is only a little bit, just the tip of the iceberg. So what is computer engineering? Kind of a pretty basic definition would be the design and construction of computing systems, from hardware to software, to harness technology in new, productive, and surprising ways. So that's a pretty all-encompassing definition, but doesn't really give too much of an idea of what computer engineering really is. So what do computer engineers do? What we do is we unite hardware and software to accomplish a wide variety of computing tasks. And this involves designing computing systems that are embedded in almost every automated device. This has to do with your phone, your smartwatch, even how your stove, functionality works with the time, and your microwave. I mean, there's all sorts of places where you have these small, little special purpose computers that you'll find everywhere, in addition to how your laptop works, how your car works. So to kind of break it down a little bit, you might be wondering, okay, well, what's the difference between computer engineering and like electrical and computer science? It's a pretty common question. I get it all the time. And electrical engineering is hardware. It's on the hardware side of things. You think something like wires and chips, boards, signal processing, kind of this more like low level look at the actual what's going on at like a basic physical level. And then you have computer science, which is on the opposite side of the spectrum. That's software. That's when you think of programmers, people who code. This is a little snippet of something that was in one of my intro coding classes. That's computer science. That's very non-physical. It's all typing and really cool. Coding is super fun. Highly recommend giving it a try if you even have the slightest interest in it. And computer engineering is really right in the middle of these two. It's computer engineers, the ones who kind of find where these two overlap and interact with each other. It's kind of the perfect marriage of the hardware side of things and the software side of things, and how do you have code running on hardware, because that's what happens in computers. So this is just a quick visual of some applications and things that people who graduate with my degree end up doing. So at Apple, working on wearable technology, fitness tracking is a huge application. Really interesting use of sensors and cellular networks to accomplish everything that a smartwatch can accomplish. And that involves a huge knowledge of systems that range from interconnectivity to how do you relay sensor information to databases and servers and whatnot. Another look is down here on the left, autonomous vehicles. That's a really big industry, right? That's up and coming right now, and I have a lot of peers that are looking at that industry. Advanced mobility, how do you get cars to talk to each other and sense the world around them? In the top here, we have this is actually a picture from my university. Someone's currently programming this autonomous robot. This is from a class it's an upper level class. It's a senior design class. We actually design a small autonomous robot. Really neat. On the right, Boston Scientific, you might have heard of them. They have a number of really neat projects that they do. Most notably their robot dog and their other really cool robots that do fun tricks. You should definitely check out their videos if you haven't already. But yeah, just again, kind of hitting home this idea that computer engineers bring together the code and the physical applications of all sorts of different industries and like really provide like physical solutions. Down here on the right, there's all sorts of things in healthcare as well. So if you're looking at something like medicine, but you're maybe not so certain that you want to be a doctor, definitely looking at biomedical engineering. I have a couple friends who are doing like computer engineering as their undergrad and then are looking at like biomed as a master's and seeing how they can apply their computer engineering skills to these systems. So, I mean, developing sensors and systems that track blood flow and heart rate, that has everything to do with taking sensor data and displaying it on a screen or taking action on it. Yeah, for sure. And then, of course, kind of what we love as well, like on the more fun side with Xbox and PlayStation, that's definitely an application of computer engineering. I mean, you need all sorts of knowledge of computing and of relaying wireless communication to develop those systems as well. Concentrations and career paths for computer engineering. This is a list actually from my university. These are all the different focuses within our major, and there's just a wide variety. I won't go into depth on each of these, but definitely check these out if any of them spark your interest. The concentration, if you're curious, and you're welcome to ask me questions about it at the end. I'm kind of in a mix between embedded systems and robotics. So why might you want to major in computer engineering? This is, of course, a question I asked myself when I started out, and hopefully this will help you maybe see if it's something that you're interested in as well. Of course, it kind of started for me with, okay, I enjoy math and science. You know, that kind of is a check in the box, like you're going to be taking math classes, math is going to be everywhere. And then that kind of scientific mindset of, yeah, I want to solve a problem. I need to, you know, take a stab at what I think is the right answer and then test it. And then if that doesn't work, then try something else. If you've taken a CS class, computer science class, or are interested in it, but want to be a little bit more hands-on, I was a little bit concerned when I started out that I wouldn't be building something. I felt that it wouldn't be physical enough for me. So computer engineering is a really great path for people who are interested in CS, but really do want something that's more hands-on. Another thing is the really neat thing about computer engineering is you've developed the skills to transform ideas into physical solutions. That's the really neat thing. In my class this past semester, we were able to develop a small robot to maneuver through a field of obstacles while following a light source. And didn't have a super practical application. We kind of had to adjust due to everything with COVID, but we originally been trying to develop a system that would help retrieve items for an elderly person who couldn't get up and get it for themselves. So there's all sorts of really neat ways that you can take your ideas and create a solution for it using the skills you learn as a computer engineer. Also, if you're interested in the future of computing, I didn't know much about this when I started out. So I was kind of like, okay, sure. You know, people were like, well, if you're really excited about computing, you should look at computer engineering. But it really is true. If you see how computers are affecting every part of our lives, from, you know, the moment we wake up and use our phones to how we get in our car, we start, you know, talking to the system in our car until we're asking it to do things for us. And they say that and not too long from now, we're going to start talking to all the appliances in our house. I mean, has everything to do with taking analog signals and turning into digital signals. And that's one of the core concepts of anything that has to do with signal processing and relaying that information in a way that's accurate and you're able to take action on it. Another thing is, like, if you're indecisive about choosing electrical or computer science, and both sound really cool, take a look at computer engineering. It kind of is the best of both worlds. And the good news is that if you do computer engineering and are really just wanting to be a CS person, you want to program till the cows come home, like, you can for sure do that too. You have the background to deep dive in that direction, or go in the opposite direction and go towards electrical. So if anyone has any questions, feel free to ask away, or if you want to email me, this is my email, and happy to answer any questions. Thanks.
All right, great. Thank you so much. So at the moment, it doesn't look like anybody has any questions. I'll wait a few more seconds before we go ahead and start our next presentation. But if anybody has any questions for Jillian, you can go ahead and ask them now. All right, well, it doesn't look like anybody has any questions right now. So what we'll do is, if you do have any questions that pop up within any of the upcoming presentations, feel free to let us know in the live chat, and then we will go ahead and address them at the end. All right, so our next presenter is Meghana, so she can go ahead and present right now.
All right. Yeah, so thank you so much for having me today. I'm super excited to be here to talk to you all about why I am so excited about bioengineering and engineering in general. Okay, sorry. So let me go ahead and present that. Okay, so I am currently a rising senior at the University of Pennsylvania, and I'm studying bioengineering and minoring in philosophy. So so bioengineering, or BE, is a really, really broad field. It's almost like you are exposed to every single different type of engineering that exists. Um, and I how I define it, I like to define it as the application of engineering principles to understand, analyze, and make progress in the biological sciences. And one of the reasons that I chose to pursue bioengineering is because I really love applications of science and hands-on work. And to me, I think that the human body is honestly one of nature's finest engineering marvels. Some of the questions you can ask and answer with tools in bioengineering are, for example, how do you model blood flow with fluid dynamics? And can we model the brain's action potentials with electrical circuits? So it's really, really cool to be able to break down some of the complex biological phenomena that you see into simple math and physics that we can use and analyze with bioengineering. Um, so BE, as I mentioned before, is the combination of mechanical, electrical, engineering, computer science, physics, math, which equips you with several tools, critical thinking skills, and exposure to ways in which you can use engineering to truly make a difference in biology and medicine. Um, and just one thing that I really, really am fortunate about and grateful to be at Penn is we have this space here with tons of tools and tons of equipment that we can use specifically for bioengineering labs. And there's one course in our curriculum where it's just dedicated to doing and bioengineering labs. So this is that space that we can use. And speaking of bioengineering labs, I just wanted to talk about one of the cool things that we do. One thing that we do is this human cockroach machine interface. So here is, if you're fans of Super Smash Bros., one of the project groups did Super Smash Roaches. So basically they had the two characters dueling with each other with these cockroach legs. And basically what the project is that you use your muscle movement. So on your arm here, you can attach electrodes, and with the movement of your arm, you can control the movement of the cockroach legs. So I think that's a really, really cool application of engineering. Bioengineering in particular is you're using your own muscle physiology to see to control movement of something that's external to you. So speaking of lab work and teamwork, engineering is not just a science. You have to be able to communicate and be able to work effectively in a team. You have to be a creative, a good team player, and also willing to play to each other's strengths. And it's not just science, it's also a lot of writing and being able to present. So you really, really gain a lot of good public speaking skills, as well as learning how to effectively communicate your results to both scientific and non-scientific audiences. I can go into it a little more in depth, but a lot of students don't end up pursuing engineering as a career. They end up doing like finance or business related fields. And in business, as some of you may be familiar, being able to deliver an effective pitch and summary of what you're doing is super, super important. So that's a really, really useful skill that you gain by doing a bunch of engineering projects like this. Another interesting engineering project that I have really enjoyed doing is using the cell phone camera. So using my cell phone camera, for example, being able to analyze data from a cell phone to estimate what my heart rate and breathing rate is. So I use MATLAB, which is a computer programming tool, to be able to extrapolate data from my cell phone to be able to see what my heart rate is. So that's just another really cool example of how you can use bioengineering principles and overlap computer science and physiology to understand how our body works. As I think a big theme here is that bioengineering is just truly, it's one of the broadest fields there is. So this is just a screenshot from Penn's bioengineering page. These are just a list of some of the many different research fields that you can go into. So you can find a project and subfield of bioengineering that you in particular are interested in. For example, if you're interested in computational side and you want to do more coding stuff, you can ask questions like, how do proteins and cells interact with each other, and what implications does that have for the larger organism? So you can do systems bioengineering or computational neuroengineering to answer questions like that. If you like tissue engineering, which is something that I'm really interested in, there are different types of subfields, for example, cardiovascular tissue mechanics, or just broader tissue engineering, where you can explore topics like, how do you look into organ regeneration with stem cells? So the sky's truly the limit for what you can pursue in bioengineering. And usually in college, during your first 2 years, you take more introductory level courses in bioengineering to understand like the different subfields. But then once you are exposed to all of that, then you can like choose what you really, really want to dig into. And just to go a little more into my particular journey. So as I mentioned at the beginning, I'm minoring in philosophy, which is a slightly less common path. But the reason why I decided to do that is I'm really interested in just uncovering basic principles of nature, human behavior, reality, and existence. And it goes hand in hand really well with my BE studies. For example, I've taken classes in philosophy of science to really dig into ideas such as what makes a scientific theory a theory, and how we justify the scientific process. And also, just a tangent, I've taken classes in global justice, which is especially pertinent in today's pandemic, as you all probably can imagine. And we're digging into questions such as, does the US have a moral obligation to help lesser developed countries if they are struggling with COVID? So I think philosophy is so if you really like asking questions and want to really dig into why you do certain things, whether it be in science, political science, just any field, I think philosophy is a really, really good field to get into. And I'd highly encourage you all to take a philosophy class or consider pursuing a major or minor. And then I just have this additional image here to lead into discussion of a few careers in bioengineering. So just as there's so many different topics you can explore in bioengineering, there are also several different careers that you can pursue in bioengineering. You can manage research and development in biotech companies. You can evaluate new medical technologies for venture capital firms. You can form startup companies, as I know a lot of Penn alums have done. You can pursue academic research and teaching. In my case, I'm actually I'm applying to medical school because I'm interested in becoming a physician. So that's another common, but not a super, it's not in the majority by no means. And as I mentioned, you can also really get into the business side. So I know a lot of my classmates and peers are pursuing double degrees within the Wharton School of Business. So they really are interested in the business side of technology and engineering, which is extremely relevant in today's society. Yeah, so that's basically a brief overview of bioengineering and my path. I just also want to add that as a female in engineering, I know that before I came into Penn pursuing bioengineering, it did seem a little bit intimidating, seeing that I was in the minority. But I think just seeing that the three of us presenters here today are all females in engineering, it's really inspiring and encouraging to me. And I hope that all of you who are watching are also encouraged to see that the gender disparity in engineering is it is equalizing now, and hopefully that excites a lot of you to pursue engineering as well. And I would be happy to answer any of your questions through email or now if they come up. Yeah, thank you.
Awesome, thank you so much. I'll wait a few seconds to see if anybody has any questions, again, for either of our two presenters so far. And if not, we will just jump in to our third presentation, and then we can save any questions that come up for the end. So yeah, if you have any questions right now, you can go ahead and let us know in the chat, and then we can address them now, or we can also wait until the end as well. All right, so we have one question, which is, would you comment further about how your field relates to business?
Yeah, so I think a lot of the potential careers are, there are a lot of bioengineering technologies being developed, and a lot of people are really interested in sort of elevating new technologies and bringing them into having startups and really having investors invest in those startups. So I think business really equips a lot of students with the knowledge of how they can successfully bring their technologies into the business world. I just off the top of my head, like Medtronic is one of the world's largest medical device companies, and if you're an engineer, that's great because you are contributing directly to the development of important medical devices, but having the business knowledge will also give you a leg up, because then you will be able to really use your engineering knowledge to be able to say, hey, this is a medical device, the technology works this way, and you can really bring that device into the business world. So I think that's one of the main reasons why I know a lot of my peers are pursuing business, because in the end, that's something that they want to do. They another really popular career that people pursue is consulting. So with your technology background, you have that expert to be able to consult with large businesses on how they can use certain technologies. So I think that engineering fundamentally is such a great field and great career to pursue, because you are equipped with so much technical knowledge that a lot of people don't have. So being able to, even as for me, like I want to go to medical school, but and pursuing bioengineering is not super common, but I believe that having that knowledge will definitely help me in being able to communicate why certain devices are being used for certain diseases and stuff like that.
All right, great. Thank you so much. It doesn't look like we have any other questions, but if you do have any other questions that pop up, feel free to let us know in the chat. Actually, there's one more question that just popped up, which is biomedical engineering a branch of bioengineering?
Oh yeah, that's a good question. I should have clarified that earlier, but some schools say it's biomedical engineering, some say it's bioengineering, but in essence, they're both the same thing. So yeah, that's a good question. Good clarification.
Perfect. So now we will go ahead and move on to our last presenter, Arya. So she will take over right now. And if you have any other questions that pop up for either of our past two presenters, feel free to let us know in the chat.
Sounds good. Let me try to get this screen sharing working super quick. All right. Is that sharing the slides or the speaker notes? Can you guys tell? Let me just make sure. Okay, hopefully this looks all right. Fingers crossed. I'm definitely not very savvy when it comes to Zoom. But anyways, if anything looks weird, feel free to let me know. Anyways, yeah. Thank you guys so much for having me on this virtual STEAM engineering night. I'm really excited to be here and talk a little bit about my experience in engineering so far. My presentation might look a little bit different than the previous two, because I just finished up my freshman year and actually just declared my major. So I don't have a ton of experience in mechanical engineering so far, but I'll just talk a little bit about my path, to declaring my major, what this past year has looked like, and kind of everything that's led up to it. So we will go ahead and get started. So just a little background on me. I was born and raised in Boulder, Colorado. Boulder is a super cool city. There's a lot of awesome things to do outdoors, from hiking to skiing, running, biking. I attended elementary school, middle school, and high school here, and I really just didn't want to leave. So I am at CU Boulder. And throughout school, I was always pretty interested in math and science classes, but I haven't always known that I wanted to be an engineer. I always thought like math and physics was really interesting, but it took me a long time to really decide on engineering as a profession. So during my junior year of high school, I had this really awesome physics teacher, and he was a super strong advocate for women in STEM, just pursuing careers in science and engineering. And yeah, I really enjoyed his class. And this was the first time that I think I really started to think about pursuing math or science as a career. So after my junior year, I kind of wanted to get a little bit more hands-on experience. So I decided to start exploring some internship opportunities. Boulder's really awesome because we have some really cool labs here. So I had the opportunity to intern at NIST, the National Institute of Standards and Technology, over the summer. I worked in the time and frequency division. I thought this division was really cool because they work to maintain and they work with the atomic clock. And while I was unfortunately not working with the atomic clock, I still got to do some cool research there, studying pulse propagation in optical fibers. And this is kind of the foundation of how the internet works. Pulse propagation is how we transmit information around the world. So it was really cool to get to research this a little bit. So yeah, this internship was a great opportunity for me to get some hands-on experience. And I think this is really what cemented my desire to pursue studies in a STEAM-related field. So I thought this physics research was really interesting, but I kind of sought something a little bit more hands-on. So this is when I started to sort of think about pursuing studies in engineering in college. So CU Boulder hosts this annual event that's kind of aimed to promote engineering to women. So it's just like a Women in Engineering Day. And this is where female students can kind of come and learn more about engineering at CU and just pursuing careers in engineering in general. And I attended this event. I was really impressed by what I learned. And this kind of, got me hooked. I think engineering was really what I was looking for, kind of just this field that you're able to take these really cool things you're learning in math and science and apply them to solving real world problems. So that was a really cool notion to me. So yeah, I got really excited about engineering and applied to CU Boulder and just finished up my freshman year there. So I'll talk a little bit about what my freshman year looked like. And oh yeah, I have kind of just these pictures on this slide here, and I haven't really explained the last two. But anyways, this summer I'm actually really excited to have an internship at Northrop Grumman. So I think internships are just such a valuable experience to really get to take everything you've learned in school and apply it to the real world. So based off my previous experience at NIST, just an amazing opportunity to get to really apply those skills. So I'm looking forward to interning at Northrop Grumman this summer. And I've also just been riding my bike a lot lately because in quarantine there's really not that much to do. So So moving on, I'll talk a little bit about what engineering at CU's really looked like for me so far. There are so many different programs to pursue at CU Boulder, from aerospace engineering, applied mathematics, architectural, biomedical, chemical, civil engineering. The list goes on and on. In addition to that, there are also a lot of minor and certificate programs that you can pursue. One that I'm pursuing right now is the Engineering Leadership Certificate. So you just take some leadership classes in addition to your engineering classes. And I think these leadership classes are really interesting because leadership is a pretty vital component to engineering. A lot of engineering involves working in groups of people. So I think being able to really develop your leadership skills is super valuable. So going into my freshman year, I actually decided to declare aerospace engineering. I've always been really interested in space, so I figured, why not give it a try? So as a freshman, most of the classes that you're taking aren't major specific, so they're pretty general to engineering as a whole. And a lot of it involves these core classes that are part of a math science sequence. So these classes include calculus, differential equations, kind of just your math classes, then other science classes like physics and chemistry, computer science. So yeah, just a lot of these core classes. So as a freshman, you also have the opportunity to take an engineering projects class. So I took this cool class. It was called Gateway to Space, and we basically built a balloon satellite. You can see in this slide. Here we are. It's basically, yeah, this CubeSat that you attach to a balloon and you launch up into the atmosphere, and it goes about 100,000 feet up into the air. You're running science experiments on these balloon sats, and you're able to collect some really cool data. So that was kind of my first experience with an actual, I guess, engineering project. So this Gateway to Space class was really a fun time. And again, just kind of cemented my desire to continue to pursue studies in engineering. So yeah, in addition to this Gateway to Space class, the only really major specific class I took was a material science for aerospace engineers class. This was very interesting, actually. And yeah, it was really cool to learn about how material properties are like vital to the functionality of, everything from hip implants to jet engines. So that class was really interesting to me. But it was really only the major specific class that I took last year. Yeah, and in that class, we also got to do some really cool labs. It was kind of the first time we got to actually work with some of the testing equipment. So we did some tensile testing to determine the strengths of different materials, and that was really interesting. So overall, yeah, I thought aerospace engineering was really interesting, but I kind of figured that I wanted something a little bit more broad. So I was definitely interested in aerospace, but I also knew people pursuing studies in, I mentioned all these fields before, environmental engineering, chemical engineering, electrical engineering, and, all of these fields just sounded so interesting to me. It was really hard for me to just declare one and just focus on one because, yeah, just kind of this broad interest in these different fields. So I did a little bit of research and soul searching, and then I ultimately decided that mechanical engineering seemed like the discipline for me. So I actually just switched my major and declared mechanical engineering a couple weeks ago. And I'm really looking forward to it. I think it'll be pretty exciting. And in addition to that, I'm also looking at pursuing a major in applied math. I took some applied math classes during my first year at CU, and I just thought these classes were really interesting. It's essentially, taking mathematics and sort of similar to engineering. And it's really nice because the applied math sequence fits pretty well with the mechanical engineering curriculum. So I'm really looking forward to the next couple years, seeing what these two majors are like. All right, so in this slide, I'll kind of talk a little bit more about the specifics, or at least what I've learned so far about what mechanical engineering and applied math really are. So mechanical engineering, like I said before, is one of the most diverse and versatile engineering fields. It's essentially the study of objects and systems in motion. So this is a very broad definition. But yeah, it's interesting, I think, because people who graduate from mechanical engineering programs go on to work in aerospace, bioengineering, design, consulting, manufacturing, plant operations, power generation, alternative energy, petroleum, transportation, just to name a few. So yeah, like I said, just very broad. There are a ton of different things you can do with that. And again, I'm still really interested in aerospace. So I'm hoping that in the future, as a mechanical engineering graduate, I'll be able to work in the aerospace industry at some point. And some potential research areas, I know these are pretty specific to CU Boulder, and there's just a huge range of research going on at schools across the country. But I know some big areas that CU is focusing on includes air quality, biomedical materials, micro and nanoscale, robotics and system design, and thermofluid research. So lots of cool things going on there. As for applied mathematics, I won't spend as much time on this, but just to kind of sum up what applied math really is, it essentially involves modeling problems from a variety of areas, including business, engineering, and science. So taking basically math and using it to model phenomena in the real world, which I think is pretty cool. And some research areas in applied math include computational mathematics, mathematical biology, mathematical geosciences, statistics and data sciences, etc. So yeah, I just kind of want to touch a little bit about trying to get involved in college, because I think this is one of my biggest takeaways from freshman year. And honestly, one of the coolest things about college. I think freshman year is really just a cool opportunity for you to get involved and engage with your passions through a bunch of different means. So I know that CU Boulder and all schools just have a ton of different clubs you can get involved in. Some of these are engineering specific. I know that, yeah, during my freshman year, I participated in a club called WOA, which is Women of Aeronautics and Astronautics. Yeah, and basically this just advocates for inclusivity in space exploration. We basically just hang out and talk about opportunities in aerospace. We had the opportunity to attend some really cool aerospace conferences, network with industry professionals and faculty, and just talk about all the cool things happening in the space industry. So that was really fun. We also have a club called Engineers Without Borders. I know this is a nationwide sort of program. And basically, the premise of this is to design and implement engineering projects that empower communities to meet their basic human needs around the world, which I think is really inspiring. And yeah, I know that CU and many other schools just have a ton of phenomenal resources for students, whether this be like mentorship or, just kind of help in general. And I know CU has some programs that are designed to support students who are from traditionally underrepresented groups in engineering. So we have a program called Broadening Opportunities Through Leadership and Diversity that really empowers students from these traditionally underrepresented groups to pursue their goals in engineering. And that's been really cool to learn about throughout this past year. So yeah, there are also lots of opportunities to get involved in research. And even as an undergraduate, I was pretty surprised. I was thinking, a lot of these positions would kind of be reserved for people more at the graduate level, but there are a ton of opportunities to get involved. I know at CU, there's a program called Colorado Space Grant Consortium, which is funded by NASA, and it basically gives undergraduate students access to space through projects like these real-world hands-on satellite programs, which is really interesting. And there's also programs just specifically designed for undergraduate research as well as independent studies. So, the sky is the limit, and there are tons of ways that you can get involved even during your freshman year. And there are also just lots of other clubs and organizations just outside of engineering. And I think it's really important to try to find a balance. I mean, engineering's a pretty hard major, and you're taking some challenging classes. It's, pretty time consuming, and yeah, as fun and interesting as it is, it definitely takes a lot of hard work and takes a lot of dedication. So I think it's important to try to find a balance with other things outside of engineering and outside of school. So at CU, I've had the opportunity to be on the triathlon team, which is really fun. And yeah, I just, encourage you to, make sure you're maintaining that balance, and, just, I think, important lesson in life. So yeah, that's basically all I have. I'd like to open it up to any questions if you guys have any. And also, if you just happen to think of anything later, or you're watching this later on, feel free to shoot me an email. It's just listed on this slide. So yeah, thank you guys again for having me. And I'd love to take any questions.
Perfect. Thank you so much. So it looks like right now, it looks like we have a few questions. So let me see. The first question pertains to Meghana. So if you want to answer this question, okay, so it's what are some recommendations for activities and classes that we can do now to pursue the field later? And that specifically focuses on the biomedical engineering aspect of it.
Yeah, good question. So I know in high school, I know it's not available at that many high schools, unfortunately. But for me, I did Project Lead the Way classes, which are really inspiring and sort of informative asked me for what sorts of things I could pursue in terms of engineering. But I know that's not available at all high schools. So another thing you can do is possibly take computer science courses, maybe get involved in research early on, whether it be biological research. So as I mentioned, bioengineering is just so broad. So if there's just anything in it that interests you at all, like I would definitely encourage you to just really pursue it, do your own research, reach out to professors, and also just don't feel pressured to really feel as if you have to have everything figured out before you even start college. I know like all of us presenters, I'm sure, like felt indecisive going in. So freshman year is just a year of exploring, really find what interests you. And so during freshman year of college, you can take intro engineering courses, take a few bioengineering courses, take a few computer science courses, for example, and you can also get involved with activities in college and in your freshman year of college as well. So don't feel pressured. Again, just explore, find what interests you. There's plenty of time to commit later on.
Perfect. The next question is for anybody, I believe, which is what kind of hands-on experiences have you been able to do in your classes?
I can answer this one. So to start out, there isn't too much. So if it's something like calculus, there isn't too much. But usually for like physics labs, they'll usually have your typical like hands-on experiments. With when you get at least in my degree program, when you get a little bit further on, you will have projects. So you'll typically have like lectures and exams, and maybe like some quizzes and homeworks, but then like the bulk of the work that you do are projects. So in something like a computer science class, you'll have some programming project. You have like 2 weeks to complete it, and then turn it in, and it'll auto grade for you. And if you give it the right if you get the right output, then you get all the points. Since I'm computer engineering, I'm also taking some more like hands-on like building things classes, which have only just come about this year. So like I said, in the past semester, like built a small robotic system to navigate like a field of obstacles. And then of course in your senior year, you do like a major design experience. And that's what I'll be doing next semester. And that's kind of like your capstone or like your big final project where you take everything you've learned in the past 3 years and build something and then present on it.
Great, thank you so much. Another question that popped up is what unique advantages do you have as a woman engineer?
I guess one of the biggest things is just the solidarity that we have being females in engineering is one thing that I've really enjoyed. And as Arya mentioned, in terms of student organizations, there are tons of organizations specifically focused on empowering women engineers, such as Society of Women Engineers, which is a national organization. So you really get to meet and connect with others who are like you, who are women in engineering. And yeah, so I think for me, like the biggest thing is just the community aspect. And I'm sure the others can touch on like potentially employment opportunities as well.
Yeah, I can jump in on this one. I think it's like a general consensus that we need more people in engineering and technical fields. So I don't think it's too hard to wrap your head around. Like we have half of our population which are women going into technical fields. We have more women going into technical fields. It's better for everyone. There's also research in women just have different perspectives. I think in particular, you can see this if you're working at a company where the products are for women, even just like Nike, where they develop clothing for women, and and certain products for women. If you don't have that population represented in the design teams, the product isn't going to be as good. So really, and then just like I come down to like a basic understanding of like diversity. More diversity of thought means more innovation. So women are just add to that diversity, and we see that if we have more diverse teams, you're going to build a more robust and innovative product. As Meghana said, there are lots of great groups. I'm actually involved with Society of Women Engineers at Michigan, and we do a lot of really great work encouraging women to enter technical fields, even go abroad, as well as work with local schools. And so if you're passionate about bringing women into technical fields, there's so many opportunities to get involved and to serve that cause.
Yeah, and just to add some more, I mean, I think you guys have done a phenomenal job at kind of summing it up, but I think student organizations are such a vital part. Yeah, really to just this whole college experience. Like it's just been so empowering to kind of be in this group of like-minded people who really share your passions, and it's pretty inspiring. It's also been really cool, I think, to just see the push that colleges themselves have had, just trying to bring more females into engineering. I know that CU, and I'm sure so many other schools, are working really hard to try to get that 50-50 gender distribution, which yeah, we're getting closer and closer to doing it. I think it's just awesome to see the progress that's being made there. So yeah, it's a really awesome time to be a woman in engineering. And I'm sure, it's just going to continue to get better and better. And I'm excited to see what the future holds.
Perfect. Thank you so much. So as we wrap up, if you have any other last minute questions, feel free to ask them in the live chat. Another question that popped up in the live chat is, what are the best resources to look for an internship or co-op opportunity?
All right, I can jump in on this one. Yeah, there's so many resources. Usually if you get on campus, there'll be a career resource center that you can go to, and they'll usually have like a website that'll point you in the right direction. One of the biggest things that helped me was once you declare your major, you'll usually get on an email list for opportunities. And so like people will reach out to your department and say, hey, broadcast to your students that we have this opportunity available. And then they'll add it to an announcements list that'll send out like every week. Like I get a newsletter from electrical and computer engineering department with like a list of like new opportunities that they've been told about. Also, if you're part of student orgs, there will be companies that will reach out to student orgs and say, hi, we're recruiting. Please distribute this job information, this job posting information to your organizations. And particularly with underrepresented groups, a lot of companies are like specifically wanting to recruit from your membership. So I'm from Society of Women Engineers. We get all sorts of companies reaching out to us and saying, hi, we'd like to set up like a networking opportunity with your membership so that we can recruit them to come work for us. Also, career fairs are like a huge thing. Most college campuses have them, and companies usually always send people to recruit. Obviously, this fall is going to be a little bit weird, but definitely just keep your eyes open. And people post things all the time, as well as if you're less interested in industry and more interested in something like research. They're usually like research. There's like a website that has all the research positions available at your university, as well as other universities. And if there's a specific professor that you're interested in, I think Meghana mentioned that, definitely just reach out and say, hey, like, this is my background, this is what I'm interested in, this is what I found exciting about what you're doing. Would you be hiring someone for the semester or for the summer? And they're usually really responsive to that.
Great, thank you so much. And it looks like we don't have any other questions, but I will give it a few more seconds before we conclude this STEAM night to see if anybody has any other last minute questions. So if you have any, feel free to ask them now. So it doesn't look like we have any other questions. So I think we will wrap up, and just a reminder, let me pull it up really quick. We have our eCamp program, which you can register for directly on our website at literacy-initiative.org/eCamp. We also are in need of high school volunteers who can help run and lead sessions, as well as college volunteers if you're interested in finding a volunteer opportunity this summer. And then again, thank you guys so much for tuning into our virtual STEAM night tonight focused on engineering. And if you have any questions, feel free to email me directly, or if you caught any of their email addresses during the presentation, feel free to send them an email. And if you didn't catch any of their email addresses but do want to reach out to them, feel free to just email me directly and I can forward your message to them. But thank you guys again so much for your time this evening. And if you have any other questions, feel free to reach out to us. But thank you guys.